Here are essential exercises, linear approximations and differentials. These problems are from Openstax Calculus, Volume 1. Find the linear approximation ln x to y equals f of x, near x equals a for the function. Well, what they mean by the linear approximation in this problem is this function L of x equals f of a plus f prime of a times x minus a. This function is a line. This is a function which describes a line, and that line is actually just the tangent line to the curve y equals f of x at a. So that's what we're going to do. Is essentially, these are saying find the tangent line. The first one is find the tangent line at a equals 0. This is just a quick formula for that tangent line, and that's the linear approximation. So we need to find the derivative, which for this polynomial is pretty straightforward. So I'll do that. And then I need to find both f of a and f prime of a. And that's also not much here at all, actually. Well, hold on. Thought I was going to get all 0, but here I go. No, f prime of 0 is 1. So when I have f of 0 and f prime of 0, that corresponds to f of a and f prime of a because a is equal to 0 here. All right, so I just go ahead and punch that all into the formula. So L of x equals f of a, which is 0, plus f prime of a, which is 1, times x minus a. So this problem gives that L of x is equal to x. So that's, like I said, that's the equation of the tangent line. In fact, that's what the linearization is, linear approximation. It's the tangent line at a. And we can use that to approximate values of f of x near a equals 0. So an approximation, say, of f of 0.01 is just putting in 0.01 for x rather than having to put into the full function. All right, let's check out this next one here. Same stuff. Maybe I can move this equation down a little lower or something like that. But same stuff where first I find the derivative and then I plug in a. Before I find the derivative, I'm going to rewrite this as x to the minus 1 power. A lot of people memorize the formula for this derivative of 1 over x, but at least at first I want to write down all the steps of how we find that derivative. So we need to find the derivative, and then we can plug in 2 to f. So that's 1/2. And f prime of 2 is negative 1 over 2 squared. So that's negative 1/4. All right, so then we go ahead and use this formula, L of x equals f of a, which is 1/2, plus f prime of a, which is negative 1/4. And then we have x minus a. Well, now to me the question is that enough, or should we write it as in some other, should we simplify this? I think I'm sort of happy to leave it like this. And it's, of course we could distribute the negative 1/4, but there's a reason I like to see it this way. And that is because in this form, if I leave it in this form, what we'll see, in later problems is that this part, the second part is the differential. This part here is dy. So I sort of like leaving it like that. But, of course we can, without that much trouble, just express this as negative 1/4 x. Doing a little bit in my head, but negative 1/4 times negative 2. That's just 1/2, right? And 1/2 plus 1/2 is 1. So you could write it that way also, without, overdoing it, without hurting ourselves too much. Okay, let's go on to this next one here. All right. So again, using the same formula, let's see, I have f prime of x equals secant squared x. Now, if I plug in a, which is pi over 4, I'm going to have tangent pi over 4 that I need to find. That's f of a. And, we can just either memorize that or refer to a 45, 45, 90 right triangle. So I'll just draw a little sketch here, but pi over 4 corresponds to 45 degrees, and tangent is opposite over adjacent, so that value is 1 divided by 1, that gives 1. And then f prime of pi over 4 is secant squared pi over 4, and that will be 1 over cosine squared pi over 4. The cos don't go. Cosecant does not go with cosine does not go with cosecant. The cos don't go. The cosine goes with secant, not with cosecant. All right, and so this becomes 1 over, cosine pi over 4 squared. Oh man, I wrote that triangle wrong. Okay, the triangle is like this. Sorry about that. 45, 45, 90 goes 1, 1, square root of 2. All right, so cosine is adjacent over hypotenuse, so that's going to be 1 over rad 2. So therefore, we're going to get that secant squared, when I simplify, makes 2. Secant squared pi over 4 is 2. Okay, so then, those are things that we should be able to figure out whichever way works best for each person, determining those values. So, there's always the unit circle also. So it's good to do it that way. Okay. And, all right. So I'm just thinking about putting this up here also. Okay. So now I'll just put all this stuff together. We just plug this into the formula, and so there's not really, in my opinion, that much to it except knowing how to find the derivative, knowing how to evaluate the derivative at in this case, pi over 4. So that seems to be the challenge, just sort of going through the mechanics of this. So f of a we decided is 1, and f prime of a is 2. And then I have x minus a, and so that's x minus pi over 4. And I think that's a decent way to write that, but it's not to say I don't know how to write this as a expanded and combining like terms form. So I guess I'll do that too. I could write this as I'm showing here. Okay, so these problems are all available on Openstax, Calculus Volume 1, and that's available online it's open source, so it's free to look at and to use, as long as you don't sell it, I guess, which I'm not doing here. So this is from openstax.org. You can check it out, and they have these problems, and you can have these problems there. This is from chapter 4, and you can look at the answers in the back of the book to double check that I am doing these correctly. Okay, that's all.